Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we're going to use the present value PV function in Excel to find the price of an ordinary annuity. In any intro finance class, you are going to have a unit on annuities, and we professors will always have questions where we give you 4 of the 5 annuity characteristics, and you are asked to find the missing characteristic. If you want to ace those questions, this video is for you. I have prepared a question asking us to find the present value of annuity, right here. This is actually described as a car loan, but a car loan has constant payments once a month, and the amount owed is effectively the present value of an annuity. Mathematically, it's identical to just a regular old annuity that you see in a finance class. Consumer loans like car loans, mortgages are pretty much always going to look like annuities if you actually dig into the math behind it. Now, to get started for any annuity question, it's best to convert this verbal description of the annuity into the characteristics, the values we need. So we have our first characteristic here, N, number of periods. We need number of periods for our annuity. It's at 2 years left, and there's a payment every month, 12 months per year. So 12 times 2, we have 24 payments on our annuity. Interest rate, 0.5%. That's going to be 0.005. Make sure it's 0.005, not 0.5. Excel will potentially get confused if you are not careful with your decimal places. Present value, that's what we're going to find. So that gets left blank. Payment, our monthly payment is $550, so I'm going to put in $550. And future value, this is how much is going to be left on the loan after the loan matures. Hopefully, assuming it's a normal loan, you're going to owe nothing once you've paid it off. So future value will be 0. That's fairly common when you're finding the present value of an annuity, that there's no residual amount left at the end. The annuity just sort of goes away. Not always the case. When you get to bonds, there will be something here, but right now, future value will just be 0. And normally in this situation, I would have to change the signs to make my present value function work, except in this case, I only have 2 cash flows going on, and one of the cash flows is 0. So I don't need a sign on 0, and so I can make 550 negative or positive, and it doesn't matter. My function will still work perfectly fine either way. So I'm not going to do anything. Just leave it as positive value. Go to present value, type equals PV, and it shows me the parameters I need to enter. First one is the interest rate. That is the 0.5% monthly rate, 0.005. Next one is number of periods. My number of payments for the annuity is 24. Payment is the payment per month. That's the 550. I put it in. I can make this negative 550, positive 550, doesn't matter. And then F of V. And this I'm technically done because the default value for future value is 0. And my actual value here is also 0. But just in case, you maybe will see an annuity that has an actual value, we'll put in the 0 value anyways. Type, because this isn't an ordinary annuity, we can leave it as the default value. Hit enter, and I get my present value, which is basically the amount still outstanding on the loan. He's probably paid down the loan for several years at this point, and this is how much he still owes on the car, $12,409. Now, just note here, this is being reported as a negative number. That's why it's in parentheses and in red. That's to contrast it with the payment. If I had made my payment negative 550, I would have gotten a positive number. Allow me to demonstrate. Boom, now it's positive. And that is because Excel requires opposite signs for these functions. Now, if I want to be a little fancier, use better Excel practices, and most importantly, be able to reuse this Excel file for future Excel future annuity questions, I'm going to use cell references. So I'm going to clear out my values that I put in here. And instead of typing them in directly, I'm going to tell Excel, go to cell B6, B7, etc., and take the value from there. So rate was in B7 here. So I put in B7, and it will tell Excel, get interest rate from B7, and Excel will do it. I can also click to tell Excel where to go. So if I click on B6, that tells it number of periods is in B6. Payments was B9, and future value, just for completeness sake, was B10. Hit enter, and as you can see, I still got that 12,409. And now, if I change any values for number of periods, interest rate, payment, future value, I change them here, where it's very clear and easy to see what this value is supposed to be. And then this 12,000 will immediately update with the new present value. So let's do a demonstration here. Let's say we have a new question, and my car loan here is now 18 months instead of 24 months. So it's a year and a half left instead of 2 years. I change 24 to 18, and immediately present value updates. It's going to be a smaller present value. No surprise there. We have fewer payments left on the car, so our loan that's outstanding is going to be smaller. Okay, so with this single function, we can now find the present value of any annuity your professor might throw at you. One word of caution though, make sure you enter the correct interest rate. This was a monthly payment, and that means our interest rate we enter has to be a monthly rate. You might have a question that gives you a different interest rate than the monthly rate. In that case, you would need to do an interest rate conversion to find the correct interest rate, and then plug things into this little Excel table here to solve for present value. We professors like building on previous material like that, so be aware of that. Read the question carefully, because good chance that something like this might happen on an actual question you encounter. If you found this video helpful, please comment, like, and/or subscribe so that other students can find it too. Happy studying.